So we'll do a few problems. A unity feedback system has open loop transfer function as this: k by s into 1 plus 0.2s into 1 plus 0.05s. Find the phase crossover frequency. So what does phase crossover mean? It is the frequency at which the negative real axis intersection is occurring. Okay. So what is the first, we will write down what is the expression for phase. Angle GH is given by minus 90 degrees minus tan inverse 0.2 omega. You can write omega p, okay, since we want the phase crossover frequency, minus tan inverse 0.05 omega p, okay. So you can see that all the angles are negative here. So that means this angle, the phase, we can take as minus 180, because plus 180 and minus 180, they represent one and the same thing. But you can see that whatever be the value of omega p, this entire phase will be negative only. So we have to take minus 180. Otherwise you will get a wrong value of omega p. Okay. So minus 180 is equal to minus 90 minus tan inverse omega 2p minus tan inverse 0.05 omega p. Okay. So all of this will become positive and this will go on to the other side, making this a 90 degrees. This will both become positive. Okay. So that means tan inverse a plus b, how you can write? Tan inverse a plus b, so which is in this case 0.2 omega p plus 0.05 omega p divided by 1 minus 0.01 omega p square. This is equal to 90. So we know that 90 degrees will occur when only this is infinite, and this will be infinite when the denominator will be 0. So you can write 1 minus 0.01 omega p square is equal to 0. So you are going to get, if you solve, omega p is equal to 10 radian per second. Next question we have, find the gain margin and phase margin of the following system. So here we have g of s, h of s is equal to e to the power minus 0.1 s divided by s. So we will first have to find out the gain crossover and the phase crossover frequencies. Okay. So first you can write g of j omega, h of j omega is equal to e to the power minus 0.1 j omega divided by j omega. So how will you find the gain crossover frequency? At the gain crossover frequency, the magnitude will be equal to 1, right? So what will be the magnitude of this function? This is going to be, this magnitude numerator is going to be 1 because it is a phasor, e to the power j of something. So you can write 1 divided by omega. So this is equal to 1. This implies that this is omega g, finding the gain crossover frequency. So the gain crossover frequency is 1 radian per second. Then what about the phase crossover frequency? At phase crossover frequency, angle or the phase of g of j omega p into h of j omega p is equal to minus 180 degrees. So usually the angle is going to be negative. Okay. So you can see in the previous problem as well. Here also you can see what will be the phase of this, of the numerator. It is going to be minus 0.1 omega minus of 90 degrees. J omega phase will be 90 degrees. This is going to be equal to minus 180 degrees. So this is the phase crossover frequency. Now here you have to understand a very important thing. Whenever tan inverse is there, then it is not a problem. But there is no tan inverse here. Omega p is directly relating with these angles. Okay. In such a case, you have to use the radians, not degrees. Okay. So you can convert it into radians. What will you get? Minus pi by 2. This is going to be minus pi, right? So you will get plus 0.1 omega p is equal to pi minus pi by 2, which is pi by 2. So omega p is equal to pi by 0.2. So this, if you solve, you are going to get 15.7 radian per second. Now that we found the gain crossover and the phase crossover, we can now find the gain margin and the phase margin. Now the gain crossover frequency is associated with what? The phase margin, because we want the phase at the gain crossover, right? So angle G of j omega g into h of j omega g plus 180 degrees. Now you can see here that this angle, when you substitute omega g is equal to 1, you're going to get a negative angle which is magnitude wise less than 180. So you can see here, what is the angle? Minus 0.1 omega g minus pi by 2 plus pi. Okay, we will write in terms of the radians. So this, if you simplify, you're going to get 1.47 radians. If you want it in terms of degrees, then what you will have to do? 1.47 into 180 degrees divided by pi, which is going to be 84.27 degrees. Okay. Then what about the gain margin? This is equal to minus 20 log g of j omega p into h of j omega p. Okay. So this is equal to minus 20 log, what is the magnitude? 1 by omega, and omega is equal to the phase crossover frequency here. So this will be the expression. So this answer you're going to get 23.92 in dB. What can you say about the stability of this system? The phase margin is also positive, the gain margin is also positive, the system is going to be stable system.